this video number 3 on based on load calculation of air conditioning system. The subject name is refrigeration and air conditioning. So is this question, in this question, an office for sitting of 30 occupants. There is an office with 30% occupancy. This is 30 persons occupancy is to be maintained at 22 degrees Celsius drivable temperature and 55% RH. That's mean there is a office at 22 degrees Celsius and 55% RH, and with 30% are sitting in this room. This is condition number 2, as I earlier considered. In the outdoor condition is given that 36 degrees Celsius drivable. This is outdoor condition. This is point number 1. Outdoor condition is given that 36 degrees Celsius dry bulb temperature and 27 degrees Celsius wet bulb temperature. Dry bulb temperature, which is measured by the ordinary thermometer. Wet bulb temperature is the temperature which is measured by the ordinary thermometer covered with the wet cotton piece. The various load in the office are given in numerical. The solar heat gain. The solar heat gain, that means solar heat gain is in form of only sensible heat. This is a case of sensible heat. There is no humidification or dehumidification process occur. The sensible heat gain per occupant, that means there is 83% sensible heat gain per person. That means this is sensible heat gain by per person into 30 persons are there. We will calculate the total sensible heat produced by the persons, occupants. The latent heat gain per occupant, that means into 30, it is gives the latent heat, total latent heat by all the sitting persons. Lighting load, that lighting load heats, that is in form of sensible heat, because there is only increase in temperature, there is no change in humidity. There is only increase in temperature, there is no change in humidity. That means lightning load is considered as a sensible heat load. Sensible heat load from other sources. Total sensible heat load from the other sources is 12 kilowatt. That means the infiltrated load, the infiltration will also occur in this numerical. That is 15 meter cube per minute. Infiltration, in case of infiltration, the outside air is in infiltration. That point number 1 is directly mixed with point number 2. That's when outside air is directly mixed with inside air. That outside air is at point number 1. Inside condition is point number 2. Outside condition is given 36 degrees Celsius and 27 degrees Celsius. Inside condition is given 20% and 55% RH. Mark both the points on psychometric chart. This is overall inside condition. This is overall outside condition. This is overall inside condition. This is overall inside condition. This is overall outside condition. Mark both the points on psychometric chart and draw a psychometric chart based on this. So after this, in this numerical, assuming 40% of the fresh air, that means this is 40% fresh air. This is 40% fresh air and 60% of recirculated passing through the evaporating coil. That means this is 40% of. That means the 60% of recirculated air and 40% of fresh air firstly mix in a chamber. There is a mixing chamber, that is 60% of recirculated air and 40% of fresh air, which is mixed in a mixing chamber. After this, that passing through a cooling coil. These are the cooling coils. And after mixing, we got the temperature, the condition of air at 3. After passing through the cooling coil, we got the condition 4 point. That means the cooling coil temperature is given as 6. So I will explain again. I will explain these things. This is the inside condition. This is the outside condition. This is the mixing condition. After mixing, 60% and 40% is fresh air, 60% is recirculated air. After this, we got the point number 3. This is point number 3 after mixing. Then this point number 3, air is passing to the cooling coils. Cooling coil temperature is given as 6. Condition number is 6 for a cooling coil. After passing through the cooling coil, the temperature of 3 point is decreasing, and due to this decrease, we got the condition number of air condition is 4. This is 4 point which is entering to the room, through which we will calculate the capacity of the plant and dew point temperature. The point temperature is T6. This is apparatus dew point temperature, which is also known as ADP, apparatus dew point temperature of the coil. Capacity of the plant, we will calculate the capacity of plant. We calculate the mass of air circulation, and T3 minus 4 we will find out in further. I will explain the parameters in psychrometric chart. You have to take screenshot. You have to take a screenshot of this numerical, solve this numerical with me. You also have to take a printout of psychrometric chart to solve this numerical. So I will explain this numerical on psychrometric chart. Please take a psychrometric chart with you and try to solve this numerical yourself with me. So let's move to psychrometric chart. Thank you.
Friends, welcome to all of you. Now we're solving this numerical. I already explained the whole numerical to you. There are 30 occupants in the room. The inside condition, room condition is given that 22 degrees Celsius dry bulb temperature and 55% RH. This is 22 degrees Celsius dry bulb temperature and 55% RH. This is 50, this is 60. In between this, there is a 50 and 60 line. That's mean the 22 degrees Celsius dry bulb temperature and 55% RH. That's mean this is our inside condition, point number 2. If I will draw here a diagram which I explain you, this is inside condition, this is outside condition, 22 degrees Celsius dry bulb temperature dBT and 55% RH. This is condition number 2, inside condition, auditorium condition. And the outside condition is given that 36 degrees Celsius dry bulb temperature and 27 degrees Celsius wet bulb temperature. 35 and 36. 36 degrees Celsius dry bulb temperature. This is 36 degrees Celsius dry bulb temperature and 27 degrees Celsius wet. 25, 26, 27. This is 27. This is wet bulb temperature line. So this is the outdoor condition. This is condition number 1. Outdoor condition, 27 degrees Celsius WBT and 36 degrees Celsius dry bulb temperature dBT. And as per the numerical, the mixing will take place. First of all, the mixing takes place. Then there is a cooling coil. These are the cooling coils. So there is 60% of recirculated air is mixed with 40%. That means from point number 1 we got 40% air. From point number 2 we got 60% air. That means 60% of air at condition number 2 mixed with the 40% of air at point number 1. After mixing, we get the point number 3. That point number 3 is passing through the cooling coil. We get point number 4, the condition of air at point number 4, which is entering to the room. So this is the condition of coil, the temperature of coil, which is written as 6. This is point number 6. So we mark the inside condition. This is the inside condition and this one is the outside condition. We mark the outside condition. This is inside and outside condition. And there is direct mixing of 1 and 2. This is point number 2 and this is point number 1. That means 60% or 40% direct mixing will take place. So we draw a line. We draw and mark point number 1 with the 2. This is the marking, a straight line marking with the point number 1 with point number 2. This is point number 1. This is the point number 1 and this one is the point number 2. So there is a direct mixing. That 60% of recirculated air is mixed with 40% of air. That means there is decrease in 60% of temperature of outside condition. If we are using 40% of fresh air which mixed with the 60% of the 40% air is mixed with the 2. That means there is increase in temperature of about 40%. That means 30 degrees Celsius and 22 degrees Celsius. This is at a lower temperature, this is a higher temperature. The higher temperature is mixed with the lower, that means there is increase in 40%. If the lower temperature is mixed with the 1, that means decrease in 60%. So we have to measure this length. This is around 9 centimeters. This is around 9 centimeter. So we have to take through measurement. We got this length is around 27.6. This is 27.6. So it is around, we take 9 centimeter into 0.6. We got this length. If we multiply 9 with 0.4, we got this length. This is the condition number 3. We got the condition number 3 through this, the 60% and 40% circulation. After this is this circulation, after which we have to calculate the other parameter. We have to find out the other parameters. There is, I will write down over here, there is solar heat gain, which is a sensible heat gain, which is 8.5 kilowatt, which is given in the numerical. This is given in the numerical. After which one more parameter is given, sensible heat gain per occupant, sensible heat gain per person, which is equal to 83 watt into total 30% are there. This is sensible heat by per person. This is latent heat by per person, which is equal to 100 watt latent heat produced by a single person into there are total 30%. So this is the sensible heat, latent heat, solar heat gain. Then lightning load is given. Lightning load is given. This is included at 7 is because sensible heat, because there is no water vapor in lightning load. That's mean this is 2.5 kilowatt. This is given in the numerical. I already explained the numerical. This is sensible heat load, sensible heat due to other sources, which is given as 12,000 watt. That's mean which is equal to 12 kilowatt. These all are parameters are given in the numerical. There is infiltration load is also given. Infiltration load is 15. The volume is given 15 due to infiltration, 15 meter cube per minute. This is given 15 meter cube per minute. That's mean infiltration means outside air is directly, and point number 1 condition is directly entering into the condition number 2. So we have to mix point number 2 with point number 2, 1 and 2. That's mean this is the latent heat with respect to point number 1, and this is the sensible heat with respect to point number 1. We have to find out the enthalpy at this point. This is 45. This is the enthalpy at point number 1. This is this is point number 2, H2, and this is the enthalpy at point number A. This is 60 kilojoule per kg. This is HA with respect to point A, and this one is enthalpy 85 at H1. So we got the enthalpy. This is the latent heat region, because there is no change in temperature but change in humidity takes place. It is latent heat due to infiltrated air, outside air directly mixing into the room. The outside airs have some latent heat, outside the air have some sensible heat. This is the part of latent heat, this is the part of latent heat, because without changing in the moisture content, there is change in temperature from 22 to 36. In this case, there is change in humidity 0.019 to 0.009. There is change in humidity due to outside air. Outside air have some latent heat, outside air have some sensible heat, so we have to calculate the space sensible heat and latent heat at both the points. So these are the specific volume lines. These are the specific volume lines, 0.95, 0.90. That's mean at point number 1 we got approximately at point number 1 we got specific volume at point number 1 is 0.902 meter cube per kg at with respect to point number 1. So we will calculate the infiltrated and we calculate the latent heat due to infiltration and sensible heat due to infiltration. We multiply, if we calculate the latent heat, this is M M1 outside air जो mix हो रही है उसकी वजह से M1 into this is H1 minus HA. This is latent heat due to infiltration, and this one is sensible heat due to infiltration, which is M1 HA minus H2. HA minus H2. So we have to calculate the M1. How can we find out the value of M1? I will explain over here. M1 is equal to V1 upon specific volume at 1. So it is 15 given in the numerical, 15 meter cube per minute, and small v1 is calculated over here with respect to this point, because this is specific volume line. These are specific volume lines. These are the specific volume lines. So at this point there is small increase, 0.0902. So it is 0.902. We got the result. I am directly write down the result. M1 is equal to 16.63. This is the result. So after the calculating parameters, the latent heat due to infiltration, which is equal to multiplication of M1 H1 minus HA. This is 7.1 kilowatt. We have the value of H1, we have the value of HA, we have the value of M1. Multiply this one, infiltration के through latent heat कितना हुआ 7.1. Similarly, sensible heat due to infiltration, we calculate M1, this is 16.63 kg per minute. This is kg per minute. We got H1 60, H2 is 45, so we get 4.05 kilowatt. 4.005 kilowatt. So these all parameters are for the sensible heat, and these are latent heats. This is latent heat. This one is latent heat. We add both the latent heat parameters. We got room latent heat. Which is equal to 10.1 kilowatt per person. With respect to per person, we got 3 kilowatt. 3 plus 7, 10.1 kilowatt. Room sensible heat, which is equal to, if we add room sensible heat parameters, this is sensible heat 12 kilowatt, 12 plus lightning load 2.5 plus solar heat gain 8.5 plus with respect to per person 2.5 kilowatt. So by adding all these parameters, we are missing one parameter 2.6, which is around this is sensible heat due to heat gain due to lightning load. This is 2.5. This is sensible heat gain. So one more is 2.5 kilowatt, 8.5, 2.5, 3 plus this is sensible heat due to infiltration plus 4.05 kilowatt. So we get the result as room sensible heat, which is room sensible heat is 29.65 kilowatt. This is we get room sensible heat, room latent heat. We calculate the room sensible heat factor, which is equal to room sensible heat upon room sensible heat plus room latent heat. We put the value of room sensible heat, we put the value of room latent heat. We get the value 0.746. That's mean this is sensible heat factor parameter. If you are seeing this is room sensible heat factor. So we have to mark 0.746. This is approximately around at this point 0.746. So this is the sensible heat factor, room sensible heat factor. We have to find out the alignment circle. We have to mark the alignment circle in this. The alignment circle at 26 degrees Celsius and 50% RH. This is 50% RH. This is the alignment circle AC. This is fixed at, alignment circle is fixed at 26 degrees Celsius dry bulb temperature and 50% RH. So alignment circle is fixed for 26 degrees Celsius dry bulb temperature and 50% RH. We have to draw a line with the alignment circle. This is the alignment circle. We have draw a line. Always draw a line with join with alignment circle to room sensible heat factor. This is the line which room sensible heat factor is always meet with the alignment circle, and we have to draw a parallel line which is moving from point number 2, which is parallel to this one, this line. So this is the another line which is parallel to this line. So this is that I will use different color. We are using red color, dotted color for this line. That red dotted line is parallel to the green line, that room sensible heat factor line. This is room sensible heat factor line. That line, dotted lines. That's mean the point number 4, that condition is exist on this point. Point number 4 is exist on this point. So we got the room sensible heat factor, we got these points, we calculate all sensible heat parameters. We have some coil temperature. There is given as bypass factor. That bypass factor is equal to 0.12. We calculate by if you see the previous numerical, we go through bypass factor. We got the temperature, two temperature, that coil through bypass factor. We got the temperature of T6 and T4. That means these are the cooling coils. That is, we got a formula which is TdB4 minus TdB6 divided by TdB3 minus TdB6. We got this formula through this heat and trial method. We got the value of TdB4 and TdB6. We got the value of TdB4 and TdB6. We got approx value 10.7 degrees Celsius. This is dry bulb temperature at point 4. This point 4. This is point number 4. And we got the dry bulb temperature, cooling coil, apparatus dew point temperature. This is apparatus dew point temperature. This is 7.8 degrees Celsius. This is 7.8 degrees Celsius. We got this result through heat and trial method. We put the value. We have the value. We have the temperature at point number 3. This is point number 3, and this is the temperature at point number 3. This is 27.6 degrees Celsius, TdB3. We got the 27.6 degrees Celsius TdB3. We put this value 27.6, and we put the value, approx value for TdB4. Hit and trial method, we got the result at TdB4 and TdB6. This is TdB4, and at this TdB6 we got the result 10.7 and 7.8. That means coil temperature is 7.8. This is 7.8 degrees Celsius, and coil temperature is 10.7 degrees Celsius. That means we have to mark 10.7. This is 10.7. We have to mark TdB4. This is the temperature of inlet air to the auditorium, and we join these lines. We have to join these lines. Point number 3 to point number 4. We got this point. This is apparatus dew point. This is around 7.8. 5, 6, 7, 7.8. We got this result is approximate. We got 8 degrees Celsius, and this is 10.7 degrees Celsius. So this is point number 4. This is point number 6. We draw this diagram, after which we will calculate whatever we want to call capacity of the plant. Capacity of plant, we calculate the mass. We have to calculate the mass of air. First of all, we have to calculate the mass of air. Then there is a formula. This is with respect to cooling coil, refrigerating effect produced by this parameter, H2 minus H4. This much amount of air is moving inside, that producing the refrigerating effect. That's mean MA into H2 minus H4, which is equal to room sensible heat plus room latent heat. This is important. MA is equal to H2 minus H4, room sensible heat and room latent heat, through which we got the result MA. We got the result MA 2.56 kg per second. So through this we got the mass of circulation, that mass of air which produce the refrigerating effect. This is MA, mass circulating over here. MA H2 minus H4 2.56 kg per second. We have to calculate the capacity. Through this reason we will find out the capacity. So for this capacity of the plant, which is equal to MA H3 higher H3 minus H4. We got the enthalpy at point 3. This is the enthalpy at point number 3. We got the enthalpy at point number 4. This is the enthalpy at point number 4. We got the result. Through this we got the result. So 20.74 ton. It is the capacity of the plant if we divide this one, because it is using 14,000. Because we are calculating the mass. We are calculating the mass. It is kg per second. To remove the second, use the second to convert into a ton of refrigeration, we divide with the 14,000. So it is the result, final result 20.74. So thank you guys, thank you very much.
वतन वतन मेरे आबाद रहे तू, वतन वतन मेरे आबाद रहे तू, मैं जहाँ रहूँ जहाँ मैं याद रहे तू, मैं जहाँ रहूँ जहाँ मैं याद रहे तू, है वतन मेरे वतन.
Subscribe to our